Okay, so we will begin by what we started the unit off with, which was solving by graphing. So 1 and 2 are quadratic situations with a linear equation. So these two could have a possibility of at most 2 solutions. So I'm going to start with number 3. Number 3 is 2 linear equations. So at most I can have 1 solution. So this is our M and this is our B. We always start with our B. So I'm going to start with positive 2 on the first equation. Okay, positive 2 on the first equation. That's the y-intercept. My slope is negative 3, so I'm going to go down 3 over 1. Or up 3 over 1. Then on the second one, and that's because I had a negative slope, so it goes to the left. On the second one, I'm going to go down to negative 3 because the y-intercept is negative 3. I have a slope of 2, so I rise 2, run 1, and we can already see our intersection is at this point right here, which is 1, negative 1. Now remember, you can always check your solutions by taking your answer, right, and plugging it into either equation. Actually, that should work in both. So that's negative 1 equals negative 1. Alright, so for number 1, we're going to graph this we'll start with our linear one. So let's start with the x plus 3. So x plus 3 starts at 3, has a positive 1 slope. I want to make as many points as possible because I really don't know where these might intersect. So the more I put, the better. So then, in order to graph a quadratic, I need to use my formula for finding the vertex. So that formula is x equals negative b over 2a. And this is a, b, c. So b is already negative and the formula is negative, so that's 8 over 2 times 1. So that'll be 4. That's half of my vertex, not half of my solution. So then I take 4 and I plug it in for x in the original equation right there and right there. So 4 squared minus 8 times 4 plus 21. So that's 16 minus 32 plus 21 is 5. So that's my vertex. My vertex is at 4, 5. And then my A is 1, so I go over 1, up 1, over 1, up 1, over 1, up 3. Let me get a highlighter to show you. Okay, so we can see that it crosses here and here, so there's my 2 solutions. Remember, it's 1, 3, 5, which is where I got that pattern from. So one solution is at 1, 2, 3, 1, 2, 3, 4, 5, 6, 3, 6. And the other one is at 4, 5, 6, 6, 9. Okay, so we're going to jump down to number 4. Number 4, we're going to solve this by substitution. And that's how we learned how to solve a quadratic and a linear. So notice that they're both y equals. So what I'm going to do is I'm going to set them equal to each other. So when I do that, I'm going to get it equal to 0 because in the end I want to be able to factor this quadratic. So I subtract 2x because it's positive. I subtract 5 because it's positive. And so then I have x squared plus 6x plus 5 equals 0. So down here, I'm going to factor this. So what multiplies to 5 and adds to 6? There's only one pairing that multiplies to 5 and adds to 6, and that would be 5 and 1. Okay, what I noticed on your assignments, you were saying, okay, x is 5 and x is 1. X is not 5 and x is not 1. X, when you solve each parentheses, x will be negative 5 and x will be negative 1. So that means right here, negative 5 something and negative 1 and something will be my solutions. So, in order to find the y values, I take my x's and I plug it into the equation. Well, the easiest equation would be the second one. Okay, so in place of that x, I put negative 5. Let me scoot over. So that's negative 10 plus 5, and you can just type that in your calculator. Y equals negative 5, so negative 5, 5, negative 5, negative 5. And then the other one, 2 times negative 1 plus 5, negative 2 plus 5, so that would be 3. So again, once you find x by factoring, solving the factoring, then that's why, or then you would take your solutions there and you would plug it into one of the equations, and the easiest equation to plug it into is the linear one. So now what we'll do is we'll go to the back and we will work a linear one. That was a quadratic and a linear. So a linear and a linear, we solve multiple ways. Oh, there's another linear and quadratic one, so hopefully you'll have some time to set those equal to each other and solve them by factoring. So I'll let you do that on your own. The answers will be sent out later today for the review. So first one I'm going to do is by elimination. So notice that everything's lined up. And so what I want to do is I want to eliminate a letter. Well, what I could do, I could say I pick my x's. Actually, you know what? I'm going to pick my y's. So what I'm going to do with my y's, it really doesn't matter. You could pick either letter. I'm going to exchange numbers here. So this 3 is going to multiply with this equation, and this 2 is going to multiply with this equation. But the thing is right now, in order to get them to eliminate, they have to have opposite signs. Well, they don't have opposite signs right now. So I'm going to make one of these negative, and it absolutely does not matter which one you make negative. So once I do that, I'm going to multiply this all in, multiply this all in. So that's negative 4x minus 6y equals negative 192. 3x plus 6y equals 162. Cancels, negative 1x equals, so what happens is once you get a letter to eliminate, then you just add your two equations together. Whatever the signs are is what happens. And so then I end up having x to solve for, and x is going to be 30. So once I have the x, I can plug that x in anywhere. I think the easiest place would be this right here. And so in place of that x, I'm going to plug 30. So 30 plus 2y equals 54. I'm going to subtract 30 and solve for y. Sorry, a little fast for the camera. So now y is 12, but we always write our solutions as a point, so it'll be 30 comma 12. So remember, you can always take your answers and plug them back in and make sure they check out. And so if you have extra time on your test day, that's what I would do to make sure that you're getting all of them right. Okay, so let's work a substitution. Nothing right now is ready to be substituted. Now, something is really close to being all by itself. Actually, I could pick either y. The reason I want to pick the y's is because they have a 1 in front of them. So it's a little easier to solve for whenever they have a 1 in front of them. And so I'm going to pick the bottom equation. It absolutely does not matter. And so when I pick the bottom equation, I would subtract 2 over to isolate the y. So y equals x minus 2. So this goes in place of this y right here. And so when I plug that in, I get 3x plus x minus 2 equals 6. 4x, you combine your x's, minus 2 equals 6. If I add 2 to get that x by itself, 4x equals 8, x equals 2. Sorry. So then what I want to do is take this answer and plug it in somewhere. Well, the easiest place to plug it in is right there. Y equals x minus 2. So x minus 2, and x was 2, so your y is 0, and that's okay. You can have 0 as an answer. So again, you can take your answers and plug them in. I'm back in the box and in my answers. Alright, so I'll let you try number 8 on your own. Number 8 is simply taking your answer, plugging it in, and seeing that it works. I would just be careful right here. That negative is not being squared with the x. So let's do a graphing. Let's do this one. So on this one is going to be a horizontal line because it's y, and this one's going to be a vertical line because it's x. So at y equals negative 3, I'm going to come across at negative 3, put this point, and shade above. So I like to not get too crazy with my shading, so I often use arrows to show that I'm going to shade above. So then where x is negative 2, I come down at negative 2. Okay, and so then what I'm going to do from there, I'm going to shade greater than negative 2, so every number to the right would be greater than negative 2. So then on my third equation, I'm going to start at positive 1 for the y-intercept, and has a negative 1 slope. So it's coming down like that. I'm going to shade below so you can start seeing it might be somewhere in there. So then on the last one, I start at negative 2, and I have a 1/2 slope. So I go over 2 down 1, or up 1 over 2. And I'm shading above, and so what happens is those would be your corners. Let's see, I'm trying to make sure I graphed everything right. Not sure why I said 4 corners. It looks like a 3-sided figure. Okay, so The three corners should be those. So that would be 2, -1. -2, -3. And -2, +3. That's weird. So then what I do is I take my corners. I want to figure out which one of them would maximize, meaning when I plug it in, which one would give me the biggest value. So the x goes for the x, the y goes for the y. Put that one in wrong. So that would be 14 minus 2, that's 12. This one would be -14 minus 6. -20. And you could really just type them like they are. -14 plus 6. -8. So one that maximizes would be the first point. Alright, so on the last one, Kay is growing and selling tomatoes and green beans. So you can see that I already defined the tomatoes and green beans. So what we're going to do is write an equation for what it costs her to grow the bushes of tomatoes and green beans. So if tomatoes is X, we can see that it costs her $1 for tomatoes. So it's going to be 1x plus 3 for green beans, 3y, is less than or equal to $15, because that's all she can afford is the $15. And then for the land equation, it will be 1 square yard for the tomatoes and 6 yards for the green beans. And we have a total of 24. So what I need to do on this first one is subtract x. So that's 3y is less than or equal to -x plus 15. Divide everything by 3. So y is less than or equal to -1/3. That's what x over 3 turns into, plus 5. And then over here, when I subtract x and divide by 6, okay, those would be the two equations that I need to graph. Notice both of them have negative slopes. Both of them have less than or equal to. And so then I start, this is my 0, 0. So 1, 2, 3, 4. Say I start with this one. -1, 6. So I go down 1, 1, 2, 3, 4, 5, 6. Down 1, 1, 2, 5, 6. And then I run out of room. That's okay. So then on the other one, -1/3, but I start at +5. So down 1 over 3, down 1 over 3. You can see where they intersect. Down 1 over 3, down 1 over 3, down 1 over 3. Alright, so it's less than both lines, so it should be below both equations. So where it's double shaded is this area right in here. So my profit equation comes from the money that she'll make off of each type of plant. So that's 1x because it's $1 per tomato bush, and 4y for each bean. And so then what I want to do is make a little table. I want to list my points, and my corners are 0, 0, 0, 4. Sorry, I went through and highlighted them. 0, 0, 0, 4. I think this should be 1, 2, 3, 4, 5, 6, 15, 0. And then 1, 2, 6, 3. Okay, so there's my corner. So I want to figure out which one of these would help maximize her money. So that one's going to be 0. 1 times 0 plus 4 times 4 is 16. 1 times 15 plus 4 times 0 is 15. And 1 times 6 plus 4 times 3 would be 12 plus 6. 18. So we didn't actually answer it yet, since I wanted to know how many bushels of each she needs to grow. So that's 6 tomato and 3 green beans to max at $18. So any of the other questions I didn't get to, you'll have the answers sent out later today, so you are welcome to look at those. I will not be working all of them. Make sure you bring your review back tomorrow for something. It doesn't mean you're going to use it. It doesn't mean you are going to use it or not use it. So just bring it back complete for something.